Hey everybody, thank you for joining back up with me to chat about percents. So we just got finished talking about ratios and we were talking about part to part ratios and part to total ratios. So part to part ratios and part to total ratios have their place in ratios, and we saw how they both worked. But percentages are also, in a way, sort of ratios. Basically, just fancy pants part to total ratios. The way you want to think about it is like this. If I say 8 is what percent of 32, what am I really saying? I'm saying 8 is what piece of 32. How do they relate together? Yeah? 8 is what chunk of it. So what really is a percent? A percent is a relationship between part and total when the total is out of 100. We say, what would the part be if the total was 100? It's a lot like getting a common denominator. So if I say 8 is what piece of 32, that would make 8 my part, and it's out of a total of 32, so 32 would be my total. If I put my part on top here, and my total on the bottom, I have a fraction, which I can reduce if I wanted to. That would be 1 over 4. Or I can expand and make it 16 out of 64. Those would both be equivalent fractions. I could have reduced by 8 and get 1 over 4. I can expand and get 16 over 64, multiply it by 100 and get 800 over 3200. These are all equivalent things. But when we're dealing with percentages, we're always making it out of 100. And there's a lot of good reasons for that we could talk about. But for right now, we're just going to say, okay, what would be the equivalent fraction if the denominator was 100? What would my numerator have to be? Now, we all know we can go ahead when we have a fraction that equals another fraction. What do we do to solve? We cross multiply, which means we take this diagonal and multiply it together. So we'll get 32x. And then we'll take the other diagonal and multiply it together, and we'll get 800. And they equal each other. So if we divide both sides by 32, we'll get that x equals, now if you grab your calculator and go ahead and punch that out, you write 800 in your calculator divided by 32, and you'll get 25. Which makes sense if you think about it, because remember, this reduced to 1 over 4. 1 over 4, well, that's just a fourth of the total of 100, and 1/4 of 100 is 25. So we would say 8 out of 32 is the same as 25 out of 100. And so we say this is 25%. 25%. But let's remember what percent means, and we'll talk about this a little bit more. Percent actually means divided by 100. So when we say 25%, 8 over 8 is 25% of 32. We're saying 8 is equivalent to 25 out of 100 when it comes to 32. So when we see, again, the part to total ratio, 8 is what percent of 32, we think this is my part, this is my total, and we want to see how they relate together. So I'm going to talk a little bit about the triangle method for that same idea. So we have that same question. 8 is what percent of 32? We established that this 8 here is our part, and that 32 is our total. And if we want to find what percent that is, we can use our triangle. On the top part of our triangle goes our part, so we'll put 8 up there. On one of the bottom spots, we put our total, that's 32. And now you want to think about how the parts of the triangle are related together. If the top is over the bottom, very much like in math, like that can be our fraction bar, we take 8 and divide it by the 32 on the bottom. Same with the decimal part. If it's one over the other, which we'll see in a second, we divide. And that doing just that will produce the third box that we're missing. So let's try that. We have 8 divided by 32. Hit enter on our calculator, we'll get 0.25. And that is our missing spot, 25% as a decimal. Now, if I wanted to turn that into a percent, not as a decimal, I would just have to move the decimal over 2 times to the right or multiply by 100. Same thing, and that would equal 25%. Let's try another one, a slightly different question. Clean our little triangle up. What if we said, okay, 10 is 30% of what number? We're saying 10 is a certain size piece of something else, which makes 10 our part. Our unknown is our total, and this is our percent. Now, in order to use a triangle, we have to turn that into a decimal. So remember, 30% means 30 over 100. If you punch that on your calculator, you'll get 0.30. Move the decimal 2 times to the left to divide by 100. So I'm gonna put the numbers that I have on there. I'm gonna put 0.30 on here as my percent as a decimal. I'm gonna put 10 on here as my part. And I don't know what this guy is, that's what I'm looking for, right? So again, I have my part on top and my percent on the bottom, one over the other. That's my fraction bar. I'm gonna take 10 and divide it by 0.30, and that should give me my total, the piece that I'm missing over here. So we do 10 divided by 0.3, and we get 33.33 repeating, which is our total, 33.33 repeating. Now you might say, Donna, I don't believe you. Is it true that if I just took 10 and divided it by this, I'd get 30%? Well, let's see. If I take 10 and divide it by 33.333333, as many as my calculator can hold, and hit equals, absolutely, I get 30%. Now, one last orientation that we haven't considered yet. What if I have the total and the percent and I want to find my part? So a question like that might be, what is 15% of 75? So again, we have 15%. It's easy to see because that ends in a percentage symbol, that will be our percent as a decimal. So divide that by 100, we get 0.15. We're going to put that right in here. Of 75, so what is this size piece of 75? 75 is our total then, because we're taking a piece of it. That'll be 75 for our total. And we want to know what our part is. Now, these aren't one on top of the other. These guys are next to each other. Now, when they're next to each other, we'll think about it algebraically. When two things are next to each other, we multiply them. So we multiply these guys together, and 75 times 0.15 gives us 11.25. So that must be the part that's 15% of the 75. We can put it up here, 11.25, and check it out. If I take 11.25 and divide it by the 75, do I get 0.15? Let's see. 11.25 divided by 75. Punch it out on your calculator. Pause the video if you need to. And absolutely, we get 0.15. So again, if you have two pieces, either your part and total, your total and percent and part, you can always find that third part. Let's continue. Let's talk about percent translation. This is another way to take that sort of complicated percent language and turn it into math that we can work with. So we're going to take the word problem, and again, this doesn't just work with percents, it really works with any word problem. Take the words in the problem and literally translate them word for word to math. When we say what, we don't know what it is, so we have to put a placeholder for it. We make a variable. Here it's n, but you can use any one you like. I like n because x's kind of look like multiplication, so let's use n. Is in math means equals. So anytime you read the word is or conjugations of is, you can think is, are, was, yields, no, I can spell, I swear, yields, yes, would be an equal sign. Percent, the word per, when we see it on this test, please remember this. When we see it on this test, I want you to think divide. When you want to find the cost per ounce, we take the cost, whatever they gave us, and divide it by the ounce. You want to find the miles per hour, just take the miles and divide it by the hours, and that'll give you your most reduced form. Here, percent, cent, C-E-N-T, means 100. Think about it. How many cents in a dollar? How many years in a century? What does the centennial celebrate? How many legs on a centipede? The answer to all those questions is 100, because that's what cent means. So percent literally means take whatever you see before me and divide it by 100. Now of, I don't have a cute way to remember that, but of is multiply. So anytime you see the word of, half of 4 means half times 4. So let's put this translation station into action. How would we write 12 is 40% of what number? I'm going to take this guy, let's make this number 1 and put it right down here. 12, we'll write 12, is means equals. 40, we just write 40 because it's a number. Percent though, which means we divide it by 100. Of is multiplication. What number? We don't know what it is, so we make an n. So again, 12 is 40% of what number? That's our n. Now the question is, how do we solve for n? We got some options. I'm going to show you some options. So one option is to say, turn it to isolate the n by multiplying by the reciprocal of our fraction, right? We can take both sides and multiply it. I'm going to change the color just so it's clear. By 100 over 40. Watch what happens to our fraction. We talked a little bit about our units canceling out, but numbers obviously do that too. These hundreds will cancel because one's on top, one's on bottom. They're going to reduce to 1. These 40 cancel, one on top, one on bottom. They're going to reduce to 1. And we're left with n alone, which is what we were looking for. Then we can punch this into our calculator. We can go for our calculator and say 100 divided by 40, that's 2.5. Multiply that by 12, and we'll get 30. And that's the answer to our question. That's just one option, though. Should we see another option? Another option that some people like to take is to say this is 40 over 100n. Divide both sides by n. The n's will cancel, and then I have something I can just cross multiply. That's another option. Let's see another option. Some people love decimals. I love a good decimal. So we can say 12 is, what would 40% be as a decimal? Well, that would just be 40 divided by 100. That's 0.40. And then I can see that I can divide by 0.40 on both sides. And when I punch that out on my calculator, I still get 30. So lots of options. I'm going to go ahead and clear this one up for us. And let's take the next one, number 2. Let's see. If 25%, well, let's think about, we'd write 25% means 25 divided by 100. Of is multiply. 12, well, it's just 12, but it says 12%, so we'll divide that by 100. Of is multiply. S is just S. Is equals 18. Ooh, let's write that down here. 25% of multiplication. 12% of S is 18. Well, I think the easiest way to deal with this one, we could multiply our fractions together and deal with it that way. We can do that. We can say 100 times 100 on the bottom would be 10,000. And then the numerator, 25 times 12, we get 300. Multiply that by S and we get 18. We can cancel out some of our zeros here. So we get 3 over 100 times S equals 18. We can multiply by the reciprocal or do any of those tricks that we saw before. Hundreds cancel, threes cancel, and that will be our answer. 18 times 100, or 1800. Multiplying the numerators together and the denominators together, divided by 3. So we would get 1800 divided by 3, which when you punch it on our calculator gives us 600. So that's one way if we like to deal with the fractions. Another way would be to go straight for those decimals. 0.25 times 0.12 times S equals 18. Then immediately I drop this into my calculator. 0.25 times 0.12 gives us 0.03. Like we saw it was 3% before. That's the same. Of S yields 18. And again, we can divide by 0.03 here. I love turning them into decimals if you feel comfortable with that because it's easier to put into your calculator. And again, 18 divided by 0.03 will be 600. All right, so let's take a look at this last one. Give it a quick read to yourself, right? If x is 0.5% of 600, what is x? Now I get the answer to this question a lot. I get 300. Let's see if that's the right answer because we're thinking 1/2 and 600. You chop 600 in half, you get 300. Makes sense, right? Well, let's check it out. If x is equals 1/2%, means I take whatever I saw before it, the 1/2, and divide it by 100. So divided by 100. Of is multiply. 600. Okay, let's see what that is. Well, I'm multiplying a fraction times a whole number, so I'll put my whole number over 1 and multiply the tops together, multiply the bottoms together. Well, 1/2 times 600, that is 300. But then I have to do the denominator, 100 times 1. Well, that's just 100. And when I reduce, I get 3. 3, not 300. Wait a minute, how did that happen? Well, if you think about it, this doesn't actually say 1/2 of 600. It says 1/2 of a percent. So that's less than 1%. That's going to definitely not be 1/2, which would be 50%. That's a very different value. And notice again, just translating from English to math really saved the day here. Works very well. So let's try a bit of a tricky one that works with our percents and the concept of percents. This one says, a school district is forming a committee to discuss plans for the construction of a new high school. So let's extract the information as we read. Of those invited to join the committee, 15% are parents of students. So I'm going to write parents. We have 15%. 45% are teachers. So teachers, that's 45%. 25% are school and district administrators. I'm going to write admin. That's going to be, you have the 45 for teachers, 25%. And the remaining 6 individuals are students. Ooh, they gave us that a little bit differently. Did you notice that? They said 6 students, not a percent. So I'm actually giving myself a different line here. There are 6 students. Now, they're asking us how many more teachers are invited to join the committee than school and district administrators. Well, I don't know the number of teachers, and I don't know the number of administrators. I would want to take them and subtract them once I get them, but I don't have them right now. How will we do this? Well, let's see. They give us the percent of everybody but the students. That's suspicious. But I do know, since that's all who came, if I add up all these percents together, it should give me the percent of all. All is 100%. So all these guys should add up to be 100% if I included whatever the students should be. So let's think about this. If I add 15 plus 45 plus 25 plus my unknown number, and it equals 100, let's see what that unknown number will be. If I add all these guys together, 15 plus 45 plus 25, I get 85 plus x equals 100. So if I take away the 85 that they already told me about, I'll find out that my x is 15. So my percent for students should be 15%. I'm going to go ahead and put that with my students. Now, I've just noticed that my 6 students is 15% of my total. Well, this is a fun thing to notice because if I know 6 is 15% of the total, I can say 6 equals 15% divided by 100 of times the total. And notice now I can go ahead and find the total. I'm going to put that as a decimal if you don't mind. I'm going to put that as 0.15 and go ahead and divide both sides by 0.15. And I'm going to find out that my total is 6 divided by 0.15, which is 40. Now I can say, well, I know the administrators are 25% of the total. So I can say 25, this is from my admin, 25% of the total is the admin, well, that's something I can punch out on my calculator. We'll make it a decimal, 0.25 times 40, what's that gonna be? It's 10. So our administrators, there are 10 of those. Ooh, there we go. And we can do the exact same thing for our teachers. Now that we have our total, teachers are 45% of multiplication, the total, which we found out was 40. We punch that out on our calculator, 45% of 40. We can do it as a decimal or a fraction. We'll get the number 18. So we have 18 teachers. Now it's going to be very tempting because this is a student-produced response, one that you have to type in yourself to put down 18 or 8 or 10. But remember, we're looking for how many more teachers than administrators are there. So we'll take these numbers, subtract them, and we'll get our answer, 18 minus 10, which is 8. There we go. So again, this is a great trick to notice that if they give you percents and then they give you a value that's not the total, if you can link that to a percent, you can say this value is a certain percent of the total, and it can help you find the total. I'm going to show you one more little way to think about this that could be fun. Once you figure out that 6 is 15% of the total, excuse my erasures, 6 is 15% of the total, you can say, well, if 6 is 15%, then my parents must also be 6, right? That makes sense. Now, if I think about, okay, well, if 6 is 15%, if I chop that into 3, 2, 2, 2, and I chop my 15% into 3, 5%, 5%, 5%, I can see that 2 is 5%. Now for the administrators, that 25% is 5%. 5% would give me my 25. So 5 times 2 would give me the number of administrators, 10. And 45 is 9 times the 5%. And we know that that 5% was 2, so we'd have 18 teachers. So that's another way to do it if you want to just break down one of the percents. I like the other way because you can just translate it based on the question that you're asking yourself. And again, to get that set up could be pretty streamlined. But again, if that's not working for you, we have lots of different options that we can use. This is a formula you must memorize, the percent increase decrease formula. I don't say that often, but when I say it, you best do it. So percent increase and decrease is really saying the amount of change we have between the two values has what relationship to the original amount. That's what we're saying, like this amount of change that we had, how does it relate to what we started with? Was it a big chunk of what we started with, a small chunk of what we started with? So the way that we do that, the way we find percent change, is we find the change between the two values by subtracting the new value from the old value, the original value, and then we divide it by the original value. Once we have that decimal, we can multiply it by 100 to turn it into a percent. Now I'm going to remind you of the thing that most people mess up about this. They'll get the change part right, but then they'll put it over the new amount, not the original. Make sure you put the percent change over the original. So let's try a percent change formula. Let's just remind ourselves. It's change divided by original times 100. Okay, let's see what that is. So the change, so let's give the question a read just a moment. Joe made $150 last week and $180 this week. What was the percent increase in his pay? So let's think about the change. Well, it was $180 at the end of the day, but we started out with $150. What's the difference when we subtract them? We found out that our change is 30. That's our change. We're going to divide that by the original amount. Think to yourself, was the original amount the 150 or the 180? Well, he made this last week, so it went from 150 to 180. So we're going to make this our original. So we're going to divide that by the original and multiply it by 100. Again, when we punch this out on our calculator, 30 divided by 150, hit enter. Take that 0.2 and multiply it by 100, and we get 20% is the percent increase in his pay. So let's try a really tricky one. This one's really tricky because of the wording, so follow along with me. So we have in our little chart, we have different years here. We have 2012, we have 2013, we have our different subscriptions sold, we have how many in each of the years. So the manager of an online news service received the report above on the number of subscriptions sold by the service. The manager estimated that the percent increase from 2012 to 2013, so the percent increase would be double. So that's going to be two times the percent increase from 2013 to 2014. I didn't put that on there. I'm going to put that on there, 2014. So if this is the percent increase from 2014, they're saying that from 2012 to 2013, that'll be two times whatever that percent increase was over there. Now we can ask ourselves, how many subscriptions did the manager expect would be sold in 2014? So this is what we're looking for right here. Well, what can we find out that'll help us figure this out? Well, I know I have these two values, and these two values will help me find this percent increase, and that's how they relate together. So if I can find the percent increase of the values that I have, I'll be able to find the value that I want. So let's figure that out. We started out with, this is our original, and this is our new. So we'll take our new minus our original and put it over our original. So that's 5880 divided by 5600 times, my bad, 5880 minus 5600 divided by the original, which is 5600. I'm going to punch that out on my calculator. 5880 minus 5600 equals 280. In my numerator, I'm going to divide that by 5600, and that's going to give me 0.05. That's, if I multiply that by 100, which is our last step, we get that it's a 5% increase. Okay, so let's erase this guy. This was a 5% increase. And we know that that is two times whatever the other guy was, right? So if I want to find the percent increase from 2013 to 2014, I know that it will be two times that the increase from 2012 to 2013 is double whatever it is that I'm looking for, that X there. So 5% is two times whatever I'm looking for. So now I'll divide both sides by 2, and 5 divided by 2, I'm going to keep it in its decimal form, is, when these cancel out, X equals 5 over 2% or 2.5%. So all I have to do now is take this and do an increase of 2.5%. I'll show you the shortcut of how to do that later, but for now, we'll say I'm taking 5880 and I'm increasing it by 2.5%. Now, if I stopped there, I'm doing something wrong. Remember, percents are never values of themselves. They're always of something. For example, I always joke, I'm like, which would you like more, 50% of the money in my wallet or 50% of the money in the US Treasury? Everybody says the Treasury, and I say, but what, isn't 50-50? And absolutely not 50. 50 is 50, but 50% really depends what it's of. So here, we can't just add on to 2.5%. That's like not an amount you can add on. It has to be of something. So we're gonna multiply it. It has to be of something, so we're going to multiply it by what we're taking the 2.5% of, which was the amount that we started with. So if I punch this into my calculator, and I hope you're doing it along with me too, we'll get 294, and we're gonna add that on to what we started with, and we're gonna get, I got something a little funky. I think I typed that in wrong. 2.5, oops. 2.5 divided by 100 times 5880. Yes, that indeed gave me something weird. I definitely typed that in wrong. That was 147. And we're gonna add that to 5880, and we're gonna get 6,027, which is B. All right, so again, that can be a pretty tricky one. I think the language here is the hardest bit, that this is double that guy. So once we figure out what this is, we have to have it, cut it in half to get the other guy. So keep an eye out for some tricky wording like this. That can be a very challenging problem. So shall we try some? Let's go for it. I'm going to use a translation station on all these, or maybe I'll switch it up and use a triangle method on one or two. But again, either method can be used on all of these. So if I see the word what, I'm going to make a variable. Is an equal sign. 42 is just 42, but percent means divide by 100. Of is multiply. Multiply by what? 50. This is something I can punch into my calculator, and I will get 21. How about the next one? 5 is what? We don't know what it is, make a variable. Percent. What percent? Means n divided by 100. Unknown divided by 100. Of is multiplication. Use a little dot since the x looks like could be multiple things. Of 4. So we see here again 5. 5 is equals what? Variable. Percent divided by 100 of multiplication 4. Now let's think, how would I isolate my n? It's in the numerator there. Well, I have some options. I can divide both sides by 4. That'll cancel out over there. And I'll get 5 over 4 equals n over 100. And then I can cross multiply. Or if I wanted to be really simple, I would just multiply both sides by 100. Why? It's going to cancel out over here because it's over 1. And here it's going to be multiplied by the 5. So I'll get 500 over 4 equals n. Punch that out on my calculator. I'll get 125. So 125%. Because, again, we were saying what percent, so we solved for a percent. Now, let's see another way to do it, just in case that didn't feel too comfy. Here's another way. Remember, we're multiplying a whole number here times a fraction. So what do? We put the whole number over 1, multiply the tops together, multiply the bottoms together. We get 5 equals 4 times n, or 4n, over 100 times 1, which is 100. Now, if I'm solving for n, we can peel back the onion. The whole side is being divided by 100, so that's what I'm going to get rid of first. I'm going to multiply both sides by 100 over 1 to go ahead and clear my denominator. I'll cancel out here. Now remember, 5 is also over 1, so I multiply the tops together, multiply the bottoms together. I end up with 500 over 1 equals 4n over 1. Yes, because these guys reduce to 1. I don't have to write the ones in the denominator. That was just to show you that there was ones down there. We'll divide both sides by 4, and we'll find out that n equals 125. Let's go for our next one. The next one says 21 is 35% of what number? So I can write that down. 21 is equals. 35 is just 35. 35% though is 35 percent divided by 100. Of is multiplication. What number? We don't know what it is. We'll make a little n. We've seen this set up before. My favorite way, let's make this little 35 over 100 into a decimal, 0.35. And then we can divide both sides by 0.35. And we'll find out that n equals, when we punch that out on our calculator, 21 divided by 0.35. Make sure you're doing it with me. We get 60. Let's take a look at that next one. What? We make a variable. Is, we make an equal sign. 15%, that's 15 divided by 100. of, that's multiplication, 75%, 75 over 100, of multiplication, 80, just 80, not 80%, so I'll put it over 1 so it doesn't feel lonely. We can multiply our tops together, multiply our bottoms together, or my dear old favorite, make them decimals. 15 over 100 is 0.15 times 75 over 100, that's 0.75 times, I'm not going to divide 80 by 100 because that's just 80, not 80%, so we'll type in 80. Let's punch this into our calculator, typing in 0.15 times 0.75 times 80. I did that wrong. 0.15 times 0.75 times 80, and we get 9. 9 is our answer here. Let's read this last one here. A school has 30 reported absences one week and 27 reported absences the following week. What was the percent decrease in the number of absences between the 2 weeks? Now remember, we're doing change over original times 100. Okay, what's our change? Our change goes from 30 to 27. It looks like it went down 3. 30 minus 27 gives us a change of 3. What's our original? Well, we started at 30, and then the next week it was 27, so our original is what we started with. That's our 30. So put that over 30, and then we'll multiply that by 100. Again, this can be popped right into our calculator. 3 divided by 30 times 100. And there we go. We get 10. 10% is the percent decrease. Now I want to show you one more thing before we head into exponents. I want to show you one more thing that we can talk about for percents. So maybe the most useful thing I will teach you, how to increase and decrease by a percent to find the total. So let's think about it like this. If I'm going to increase or decrease by a certain percent, let's say we go out to dinner. We have a check comes and it's $68. Okay. Now I want to leave a tip for our server. I want to leave a 20% tip. So what will I do? I'll have to pay all my check, of course. I'll have to pay all the $68, but then I'll have to add on to that another 20%. Now, if I add on just that much, I've just left my server a 20-cent tip. That will give me $68.20. That is not what I wanted. My server will not enjoy that. We're meant to leave a 20% tip. So 20% of the amount that our bill was. Now, if I punch this out on my calculator, 68 plus 0.2 times 68, I'll get 81.60. I should leave $81.60. Now I'm going to show you a little bit of algebra here, do a little bit of factoring that will simplify this into a one-step sort of problem instead of a three-step one. So I'm going to take these 68s here and I'm going to undistribute them from here. I'm going to take the 68 out. I'm going to divide it away. 68 divided by 68, so I can put it on the outside, leaves me with 1. And 68 divided by 68 over here leaves me with 1, but I'm also left with a 0.20. Now, if I simplify what's in here, I get 68 times 1.20. And if I punch that onto my calculator, you'll see I get absolutely the same result, which leaves us with a bit of a formula. This was our initial amount. Then we have the 1. The 1 represents that I'm using the entirety of my original amount plus a certain percentage as a decimal. And that will give me my new total, the increased amount from the initial. Now, can I use this for decrease too? Absolutely. Say I wanted to buy a lovely sweater. It was $72. But I wanted to take off 10% because I have a 10% off coupon. All right, it's on sale, 10% off. I'll subtract from that 10% of the $72. Okay, let's punch that out on our calculator. 72 minus 10% of that 72, what do we get? We get $64.80. Now, let's do that same trick. Let's factor out the 72. What will we be left with? We'll be left with 1 minus 0.10. And if I simplify that even further, 1 minus 0.10, well, that's 0.90. And oh my goodness, that makes sense. If I take off 10%, I'm only paying 90%, not all of it, slightly less than all. 10% less, 90. So again, punch that out on your calculator, boopity boo, you'll notice we get $64.80. Wow, right? That's pretty quick. So again, we can alter our rule to include both the increase and the decrease. So for the decrease, we just change that plus sign to a minus sign. So again, this one over here, a great one to notice. It will give us the increase. This is our increase. And then we also have this guy down here. That's our formula for decrease. Try it out a couple times. See if it doesn't work for you too. Now, we can also manipulate this formula. I'm gonna add another page for a little more space here to do exponential growth. Let's think about it this way. What if I put $100 in the bank? It is gonna increase at a rate of 2% each year. 2%, well, let's see. I would have to take all of my $100 and increase that by 2%. So that would be the same as taking 100 and multiplying it by 1.02. And that'll give me my 2% increase. So I left it in there for 1 year. How much money do I have now? Well, if I punch that out of my calculator, I get 102. And say I'm a smart investor, I'm not gonna take that out. I'm gonna let that bigger amount also increase by 2%. Now if I take that and increase it by 2%, and I multiply that 102 times 1.02, I'm gonna get not just an increase of 2 anymore. I'm going to get an increase of 2 and 4 extra cents. Ask yourself, why am I not just adding the same amount? Didn't I increase by 2% again? Yes, but 2% this time was of 100. That was an increase of 2. 2% of 102 is more because it's a percent of a bigger number. So that was an increase of 2.04. And what if I took that and increased it again by 2%? I'm going to take that amount and multiply by 1.02, and I'm going to get, running out of space here, but 106.12 and some change. I'm rounding it off a little bit just to make it a dollar amount. What amount of increase is that? Well, that's going to be an increase, because increasing by 2%, that's an increase of $2.08. Maybe a little bit more than that. So you can see as we're taking the percentages of bigger amounts, the longer I leave my money in there year after year, the more I'm going to make total. Now, if you think about it, what we really did is we took that 100, we multiplied it by 1.02, then we took that and multiplied it by 1.02, then we took that and multiplied it by 1.02. Well, essentially that's just 100 times 1.02 times 1.02 3 times, and that's what our exponents are. So this takes our increase or decrease formula, and we can kind of expand it to say, I'm not just going to increase once, I'm going to increase multiple times. So we still have our initial amount. We're still multiplying it by 1 plus, or if it's a decrease that's happening multiple times, we could have a minus as well. The percent as a decimal, raised to the time, like how many times this increase is going to happen. So let's take a look at another example of this. Say I have, this is not a true story about me, but say I'm a beekeeper and I have a hive with all my bees in it. Little bees, boop, 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 little bees. And unfortunately, I have 600 bees. That's fortunate, but they are suffering from colony collapse disorder, and their survival rate is decreasing at a rate of 30% each year. can we come up with an equation that describes the situation and will let me know how many bees I have after T years? Let's find out. Well, I know I started with an initial amount. Let's see my initial amount here. I'm gonna need to, you know what, I'm just gonna copy down this formula and then we can just replace with the specifics of this problem. Let's see. So my initial amount, what's my initial amount? This is my initial amount. So I'm gonna replace my initial amount with 600. 1, is it gonna be plus or minus? Which should we choose? Well, it's colony collapse disorder. They're going down, so we're gonna take away the plus. Let's keep the minus. So it'll be 1 minus. Now the percent as a decimal is 30%. What is 30% as a decimal? It's 0.30. So I'm gonna put that here, 0.30. Raised to the T years. That's how many times the decrease is gonna happen because it decreases 30%. I forgot to write this, but each year. So I want my T to be each year. So now when I look at this, I have 600. If I simplify, times 0.70, 0.70 would be a decrease of 30% raised to the time. Now this is the number of bees I'll have as a function of the time. So you'll often see it written that way. So this represents the number of bees at time T, and that's time T. So that would be a way to create an exponential equation based off a story. Again, we still have our initial amount. This is a decrease of 30%. Oops, decrease of 30%. And that's because it happens each year. Now the question might be for the harder problems, how would we change this if we didn't say each year? What if it decreased 30% every 3 years, meaning it didn't decrease every year? Well, what we'll do there is we'll divide our T. We'll take our T there and we'll divide it by 3. So that way, when I input a 3, my exponent results in 1. So when my T is 3, that makes my exponent 3 over 3, which is 1, meaning my increase will only happen one time when my T is 3 in 3 years. So that it happens one time every 3 years, which is what we're looking for here. Now, what if it happened 3 times a year? How would I adjust that? Well, then I would want when my T is 1, I would want my exponent to be 3. In 1 year, it happens 3 times. So when my T is 1, I would want my exponent to be 3. So what would I do there? I would multiply my exponent by 3. So that would be 3 times a year. You can say that to yourself. It's 3 times the year, so it happens 3 times a year. And again, if I input an exponent of 2, or input a T of 2, then my exponent would be 6. So in 2 years, it happens 6 times because it happens 3 times a year. So you can notice those differences for the higher level questions. All right, let's pause here with these percents and I will get you the exponent video next.